Let's jump right in. We are exploring the human reward system today, basically looking at our brains as ancient hardware running in a modern world. It's a really fascinating look at a biological survival engine that was handed down across millions of years. It was perfectly calibrated to keep our ancestors alive. But, what exactly happens when that million-year-old biology collides head-on with the world we live in right now? Let's dive in and find out. So, to understand why we do the things we do today, we have to look backward. I want you to think about a time when finding a patch of fresh berries was a massive, literal life-saving win. Every single time an early human did something that bumped up their odds of living another day, their brain delivered this massive neurochemical high five. It was biology's way of shouting, "Hey, that was awesome, do that again." But here is the absolutely wild part. Your brain uses that exact same underlying mechanism today when you hear the ping of a smartphone notification. And this happens even though a text message has literally zero nutritional value. Our ancient hardware was finely tuned for an environment of severe scarcity, and now it's desperately trying to process a world of instant stimulation. And that brings us to a huge concept that scientists call the mismatch problem. Think about it. The reward circuit evolved back when calorie-dense food and quick dopamine hits were incredibly rare. You had to work hard for them. But today, we're surrounded by ultra-processed foods, instant online shopping, and endless social media feeds. These modern inventions deliver massive, rapid-fire dopamine spikes that just completely outpace anything nature ever intended for us. We are basically running a million-year-old operating system in an environment of absolute abundance. And as you might guess, it's incredibly easy for that ancient system to just get totally overwhelmed. Now, what I find really interesting here is how modern neuroscience splits this reward system into two completely distinct parts. We're looking at the difference between wanting and liking. Because, we usually think of a reward as just one big feeling of happiness. But actually, dopamine drives the wanting part, the seeking, the motivation, that itch you're craving. Meanwhile, an entirely different set of chemicals, called endogenous opioids, drives the liking, the actual feeling of satisfaction and deep pleasure. Our modern environment is just terrifyingly good at hacking that wanting loop. It keeps us chasing things like endless scrolling or junk food, generating these massive cravings, even when those things don't actually make us feel fulfilled. So we end up constantly wanting, but rarely actually liking. Which naturally brings up a pretty deep and honestly very common question. If this ancient system is so easily hijacked by modern life, why don't we just unplug from it? Couldn't we just detach completely from all these bodily rewards, ignore the dopamine, and live as purely rational, logical observers? Honestly, it sounds like the ultimate form of Zen, right? Total self-mastery, just stepping entirely outside of the biological noise to make perfectly logical choices. Well, when you actually look at the research, that myth falls apart instantly. You literally cannot step outside the reward network. Why? Because it isn't just about feeling good. If you completely unplugged from this system, you wouldn't become some calm, hyper-rational monk. You would actually experience something called abulia, or severe idynamia. Basically, it's a profound paralysis of the will. In classic laboratory studies, when scientists blocked the dopamine pathways in animals, they didn't lose the physical muscle ability to eat or move. No, they just simply sat next to a pile of food and starved to death. Because the chemical signal that says, "get up and take a bite," just never fires. So the absolutely crucial point here is that dopamine isn't just a pleasure trophy that your brain hands out after you do a good job. It is the engine of action itself. Dopamine actually spikes before you act. It supplies the critical signal telling the rest of your brain, hey, this action is totally worth the energy cost to do it. Without dopamine, a thought in your mind literally cannot turn into a physical movement. We are biologically tethered to this system, for sure. It is the very current of our motivation. Okay, so since we can't just unplug the machine, how on earth do we manage it? Well, it all comes down to the architecture of our brain. Neuroscientists separate decision-making into two distinct layers. First, you've got your bottom-up signals. These are your raw, automated urges generated by the older parts of your brain. Things like, eat the sugar right now, or check the phone. But then you have top-down control. This is the executive planning coming from your prefrontal cortex. It's the part of you that overrides a raw urge and says, actually, no, we're going for a run today because we value long-term health. So when you choose to ignore a bad habit, you aren't turning off the reward system at all. You are just using top-down control to override a bottom-up impulse. And what this means is that rationality itself actually requires motivation. Logic by itself is just information. It's kind of like a map just sitting on a table. Sure, you can logically deduce that eating a salad and getting 8 hours of sleep is good for you, but to actually execute that logical plan, your brain has to assign a higher reward value to that abstract long-term goal. You're effectively decoupling your conscious choices from your short-term immediate impulses. In order to act rationally, your brain still has to release dopamine in response to the mere idea of your future health. Now, it's really easy to think of this kind of intense self-control as a purely modern invention. We tend to imagine that top-down control only popped into existence when humans invented spreadsheets or diet culture or, productivity apps. But we have to ask, is this constant, exhausting battle between immediate impulses and long-term planning just a modern phenomenon? Actually, scratch that, it's not modern at all. Top-down control is an ancient survival tool forged right in the wild. Picture this. Early hominins find a huge bush loaded with ripe berries. The primitive bottom-up urge says, "Eat now, stay here forever." But ecologists use something called the marginal value theorem to explain what happens next. Over time, that berry patch starts yielding diminishing returns. If early humans only had that bottom-up system, they'd stubbornly stay until every single berry was gone, and then they'd probably starve trying to find the next patch. To survive, they had to use top-down control to inhibit the urge to stay. They literally had to force themselves to abandon a decent food source and go explore while they still had the energy to do it. And this brings us to one of the most incredible adaptations of the human mind: curiosity as a biological insurance policy. Think about it. If our ancestors waited for a literal famine to strike before they started exploring, they would have died of exhaustion. So evolution did something absolutely brilliant. It hardwired our brains to find novelty and curiosity intrinsically rewarding. When you explore a new environment or learn something unfamiliar, your brain gives you a hit of dopamine. We were given a proactive drive to go out and explore, to build mental maps of new territories long before a crisis ever actually hit. The sheer scale of this exploratory drive is exactly what sets us apart from everything else. Just look at the numbers here. It's wild. Chimpanzees operate in a strict, hyper-local range of just 5 to 40 kilometers. And if they encounter outsiders, it's fiercely territorial and usually hostile. Then you have Neanderthals. They were highly sophisticated, sure, but mostly regional. They moved within a 30 to 100 kilometer radius, perfectly adapted to their local valleys, but relatively isolated from each other. But then you look at early Homo sapiens. Our ancestors routinely spanned 200 to over 700 kilometers. And they didn't just walk far. They created vast trade alliances, making it so neighboring groups became safety nets instead of enemies. This massive risk tolerance and craving for novelty was so strong, it even pushed them to cross open oceans. I mean, that is a breathtaking biological bet. We expanded across the entire globe, driven by this ancient, proactive pulse. But this raises a really fascinating evolutionary mystery. Did this massive, deeply hardwired drive for exploration actually give rise to our complex prefrontal cortex? Did we get incredibly smart just because we constantly wanted to explore? As it turns out, it's actually closer to the exact reverse, because raw curiosity is incredibly dangerous. In the wild, an animal driven purely by curiosity is going to wander right into a predator's den just to see what's inside, or maybe eat a toxic plant just because it looks new and shiny. To survive our own insatiable curiosity, evolution had to build us some brakes. The prefrontal cortex expanded dramatically to act as nature's risk management engine. It didn't evolve to create curiosity, it evolved to allow us to actually survive all the massive dangers that our curiosity kept pushing us into. Let's break down the 3 massive evolutionary pressures that forced this super expensive brain region to develop. First up is mental time travel. Before just blindly running into a dark cave purely out of curiosity, the prefrontal cortex allowed humans to simulate the future. It's the voice saying, "Hold on, there might be a cave bear in there. Let me get a torch and some spears first." Second is the social brain hypothesis. As we built those vast continent-spanning networks we talked about, we had to manage incredibly complex tribal dynamics. We had to suppress our personal aggression just to maintain group harmony. And third, inhibitory control. Making complex tools, like carving a hand axe, requires you to completely ignore the immediate desire to just sit down and rest, sometimes for days at a time. The prefrontal cortex was the necessary upgrade to hold us back and let us plan. Now, I want to pause on this quote from our source material because, honestly, it entirely shifts how we view self-discipline. Living purely rationally isn't an alternative to using the reward system. It is using the reward system in its highest, most sophisticated form. Think about that for a second. When you make a choice to eat well, or suppress a flash of anger, or learn a new skill instead of just mindlessly scrolling on your phone, you're not fighting your biology at all. You are actually utilizing the ultimate high-end feature of your evolutionary hardware. You are actively assigning dopamine to your long-term values. So what we are really looking at here is the ultimate co-evolutionary feedback loop. On one hand, curiosity and that bottom-up drive for novelty provided the raw biological push we needed to venture out into the unknown. But on the other hand, it was the top-down control of the prefrontal cortex that provided the tactical foresight, the social coordination, and the mental breaks to ensure that our exploration was successful, rather than, immediately fatal. They constantly push and pull against each other to drive human progress. Modern life constantly asks this ancient mechanism to run against an environment that is literally engineered to exploit our deepest instincts. You cannot unplug your reward system. You just can't. It is the engine of all your actions. But you absolutely possess the evolutionary hardware to steer it. So I'll leave you with this thought to chew on. Knowing that you can't just detach from your ancient biology, what abstract, long-term value will you actively redirect your reward system toward today? Thanks for joining me on this explainer, and I really hope this helps you master your own ancient hardware in our very modern world.